Myself, Dr. Sushan Kirtania, working as an assistant professor in the Department of Mechanical Engineering. Today, I am going to present an advanced topic on carbon nanotube reinforced composite, which is known as the metal for the 21st century. Now, before discussing about the carbon nanotube reinforced composite, it is required to understand what is composite. The composite is a material which is formed by mixing more than two materials, such as plywood is a composite material. Composite material is three types: particulate composite material, flake composite material, and fiber reinforced composite material. In fiber reinforced composite material, the fiber are the reinforcing material and matrix material may be polymer, may be metal, may be ceramics. In composite material, though more than two material mixed and form a new material, but they kept their inherent property unchanged. Now we are going to discuss about the carbon nanotube reinforced composite. Now the question is carbon nanotube. Why carbon nanotube? The composite in fiber reinforced composite, the fibers are graphite fiber or boron fiber or carbon fiber. So here, if we can replace this conventional fibers by carbon nanotube, this is the question: can we replace? We can't replace this conventional fiber by carbon nanotube or not. That we will discuss. Then another question is, what is the nano? Carbon nanotube, what is the nano? So we are going for a background about the nanotube. So there are plenty of room at the bottom. A lecture delivered by the American physicist Feynman at the California Institute of Technology in December 1959, and which is considered as a seminal event in the history of nanotechnology. Professor Taniguchi of the Tokyo University first defined the term nanotechnology in 1974. And carbon nanotube was discovered by Iijima in 1991, and after that there was a revolution started in research on nanotechnology in different direction. Though the research started on carbon or nanotechnology in 1991, but concept is delivered by Feynman in 1959. Now we question why CNT? Why we want to replace the existing carbon fiber by CNT? The reasons, if you see the properties of the CNT, the Young modulus of CNT is 1 terapascal, tensile strength is 200 gigapascal, maximum machine component are made of by steel. What is the Young modulus of steel? 210 gigapascal, but Young modulus of carbon nanotube is 1 terapascal, and tensile strength of carbon nanotube is 200 gigapascal. And what is the tensile strength of steel? Is 250 megapascal. So this value is indicate how much strength of CNT. The other properties of higher specific surface area of carbon nanotube, electric current carrying capacity 1000 times higher than the copper wire, and thermally stable up to 2800 degree centigrade in vacuum. So these property of CNT are believed to be ideal for reinforcing material, and in future it could be used as lightweight structural composite. Now, what are the types of carbon nanotube? Carbon nanotubes is two types: single wall carbon nanotube or multi-wall carbon nanotube. The first figure 1a, it is showing a single wall carbon nanotube where there is only one layer, but in figure 1b, here there is a multi-wall carbon nanotube, and if you see the figure 1b, there is a total 5 layer. So this is a multi-wall carbon nanotube with 5 layer. Now, advantages and application of CNT reinforced composite. The advantages of CNT reinforced composite are high stiffness and strength, high interfacial shear strength, high thermal and electrical conductivity, lightweight. So this is one of the important properties. The CNT reinforced composite, the density of the iron is 7.8 gram per centimeter cube, but only the density of carbon nanotube is 1.6 gram per centimeter cube. So for aerospace application, we need lightweight but high strength. So carbon nanotube reinforced composite can achieve those properties because it is very high strength as well as lightweight. The next property is coefficient of thermal expansion. So this is also one of the important properties of CNT reinforced composite. Why? If there is a change in temperature, then there is a possibility of expansion and reduction of the component. And in aerospace, we know it may go from minus some magnitude of temperature to plus some amount of temperature. So there is a huge variation of temperature. So what will happen, that due to change in temperature, it will expand, it will contract. So there is some possibility of failure of the component. So if it is low, then the possibility also very less. Failure of the possibility is very less. And this carbon nanotube reinforced composite also having this property. Improve wear resistance, lower friction coefficient, high thermal stability, enhance fracture toughness and flexural strength. This is one of the recent review paper. The author is Kaushar et al. And they have shown that carbon nanotube polymer and carbon nanotube epoxy composite can be applied from our household to aerospace. Advantages and application of carbon nanotube. Here, application of carbon nanotube, you are going for a specific, that is application of CNT epoxy composite, ultra lightweight space structure, thermal optical coating, tennis racket, baseball bat, bicycle frame, bulletproof vest, wind blade, composite gear, electronics application such as sensor and actuator. Application of CNT metal matrix composite, automobile. The parts are brake shoe, cylinder liner, piston ring, gears, heat sink, lightweight bicycle, tennis, badminton racket. Tribological application for higher wear resistance and lower coefficient of friction. Application of CNT ceramic matrix composite are thermal barrier coating on turbine blade, lightweight armor made of carbon boron carbide nanocomposite, biomedical engineering such as carbon nanotube hydroxide nanocomposite is used for heart tissue replacement. This is one of the best research topic in the present time. Bearing, valve and other wear resistance machine part, aero engine. So what we have seen, that CNT reinforced composite, it may be polymer, it may be metal, it may be ceramic matrix composite, can be applied each and every field. Now, thermoelastic properties. We discuss about what is the effect of the coefficient of thermal expansion. So this is one of the recent paper published in 18, they have shown the variation. This curve is shown the variation of axial coefficient of thermal expansion with volume fraction, and at volume fraction nearly 10%, it is shown that axial coefficient of thermal expansion is nearly 0, which indicate that just on adding only 10% carbon nanotube in epoxy, we can achieve our desired property, that is coefficient of thermal expansion nearly 0, which indicate if there is a change in temperature but the possibility is very less, or the change in length is negligible. Now the question is, we have discussed there is a lot of application advantages of CNT reinforced composites. Now the question is there any challenges? Yes, there are some challenges such as high cost of CNT. Though day by day the cost of CNT is reducing, the fabrication of CNT reinforced composite also very difficult, because we need aligned CNT, but maximum case we will find the random orientation of the CNT, and if the length is very high, there is some possibility of CNT it will curl. So if it is in curling, then it will break easily. So we need some improved technique for fabrication. Last is dispersion of CNT in the matrix material, uniformity. If it is not uniform, so for this particular place it may be failure. So uniformity is also one of the question. So at last I will say that in future carbon nanotube composite may be used from our household application to aerospace application. This is some of the important references which I have referred in my presentation, and thank you for your attention.